Hello. Welcome viewers to my YouTube channel. Kindly subscribe at Teacher Evans. 2025 KCSE is fast approaching, and I find it very necessary to help the candidates of 2025 KCSE in revision. Today I want to help them in revising a Form 2 topic, that is equations of straight lines. Now, in this topic, I'm going to handle the following, or I'm going to revise the following areas. 1. How to get the gradient of a straight line. 2. Finding the equation of a straight line in various forms, and the forms include y is equal to mx plus c, another one double intercept format or form, among others. Number 3, how to find the y and the x intercepts or coordinates, x and y intercepts or coordinates. Number 4, finding the coordinates of the point of intersection of two lines, where the two lines meet. How are you supposed to get that coordinate? And then number 5, finding the angle which a straight line makes with either the x-axis or with the y-axis. How to find or how to get the angle which any given straight line will make with the x-axis or with the y-axis. And then last but not least is finding the angle which is in between two straight lines. Find the angle which is in between two straight lines, or the angle at the intersection. Welcome. We start with the first part, that is how to get the gradient of a straight line. Now, finding the gradient of a straight line is in two ways. One, you can be given the gradient directly. For example, you will be told the gradient of line L1 is 5. The gradient of line L2 is negative 4. That is straight. You have nothing to calculate there. If it is given directly, that is the gradient. Now we have got a scenario whereby the gradient is given, but then it is given indirectly. Now this is where the rubber meets the bullet. In fact, if you are able to understand this, then there is totally nothing that will be difficult in this topic of straight lines. I have listed various ways in which the gradient of a straight line can be given indirectly. And the ways are as follows. 1, you can be given 2 points that a straight line passes through. So it is upon you to use the 2 points to get the gradient of that straight line. For example, you can be given point 0, 0 and then 2, 4. You will use the knowledge of change in y-axis divided by change in x-axis. That is change in the y-coordinates divided by the change in the x-coordinates. So one way in which the gradient of a line can be given is if you are given 2 points that a straight line is passing through. The second way in which a straight line and the gradient of a straight line can be given is 2 points given that a parallel line is passing through. you have to get the gradient of that parallel line, and then you will use the connection, the relationship of parallel lines. Parallel lines have got equal gradients. The third way in which the gradient of a straight line can be given indirectly is given 2 points through which a perpendicular line is passing through. 2 lines in which a perpendicular line is passing through. So first you will get the gradient of that perpendicular line, then use the relationship to get the gradient of this other line that you've been asked. Remember, perpendicular lines, if you multiply their gradients, you will get -1. The fourth way in which the gradient of a straight line can be given, you can be given the equation of that particular straight line. For example, you will be told a straight line has got the equation 2y is equals to 3x plus 7. Then now you can be asked, what is its gradient? First, remember that you have to write that equation in the form of y is equals to mx plus e, where m is the gradient and c is the y-intercept. Now, the fifth way in which the gradient can be given is if you are given the equation of a parallel line. So you will use that equation to get the gradient of that parallel line, then use the relationship of parallel lines to get the gradient of this other line. The number 6, you can be given the equation of a perpendicular line. Just do the same, write the equation of that perpendicular line in the form of y is equals to mx plus c, then use the relationship to get the gradient of this other line. Then next is you can be given the x and the y intercepts. X and the y intercepts of this line. Knowing the x-intercept and the y-intercepts, already you have got 2 coordinates. You can use those 2 to find the gradient of that line. You can also be given the x and y intercepts of a perpendicular line. Get the gradient of that perpendicular line, then use the relationship to get the gradient of this other line. Next, you can also be given the x and y intercepts of a parallel line. Just get the gradient of that parallel line, then using the relationship of parallel lines, you can also get the gradient of this other line. You can also be given, take this, you can also be given the angle that a line makes either with the y-axis or with the x-axis. You can be given angle that a line makes with the x-axis or with the y-axis. Please take note that angle that a line makes with the x-axis has got this relationship, that tan of that angle is equals to the gradient of that particular line. Tan of that angle equals to the gradient of that particular straight line. So we use that relationship to get the gradient. You can be given angle that is a perpendicular line makes with the x-axis. Just use that relationship. You can be given the angle that a parallel line makes with the x-axis. Just use that particular relationship that I've talked about. What about if it is y-axis? Please remember that x and y axis, the x and y axis. Please take note, the x and y axis. If a line, the angle that the line makes with the x-axis and the angle which the same line makes with the x-axis, if they are acute angles, if the two are acute angles, then those two angles will add up to 90 degrees. Those two angles are complementary angles. So that is the only relationship. That's the only relationship that you need to understand there. And then you just use what I have said to get the gradient of that particular line. I think those are the major forms or ways in which gradient of a straight line can be given indirectly. Now, my second revision will be on the equation of a straight line. How do you get the equation of a straight line? Kindly subscribe and then get the discussion of this in my next video. Kindly subscribe and then get the discussion of this in my second video. Thank you very much. Bye for now.